Okay, good evening all. So last day we have given a papers. Today we are planning to discuss about that paper that covers basically everything that we learned during past few months. Past 2 months we learned about basics of programming. So the paper that I have given covers some main disciplines in basics of programming. So if you were not there in the class during the first 2 weeks, first 2 months, this is the best time to join the class because then here we will be discussing things from the beginning. So after today, so if you join in the class after today, then that's I think mostly meaningless because you will not be able to cover the lesson again unless you join grade 10 class in the next year. So you can maybe you can cover that from the junior batch, but not from this batch. So I think you have joined in the correct time. So you can cover the lesson from the beginning now. So let's discuss. Actually, 3 of you have submitted the assignment or the quiz. So Lashen, Passan, and Sandesh. Right? Others, I think they joined recently. That's the reason to not to submit that. Anyway, you could have done that. Just give a try. So let's discuss the questions from question number 1. So first question is asking the difference between variable and constant. So what is variable basically? What is a variable? Yes. What is the variable? Variable means, so it's like mug. In a mug, you can put tea or coffee or cool drink or water or anything. In a mug, you can put anything. So, but mug is not changing, that memory location. Similar to that, memory location will be allocated to store some value when we are doing the programming. When we are doing programming, so we allocate a memory location to store some value. That memory location is fixed, but the value stored inside this memory location is going to change. So let's write answer for that. Variable is a memory location which is used to store a change in value. Variable is a memory location which is used to store a change in value. In real life, we can store in real life we can store tea, coffee, fruit juice, or water, or any other liquid in a mug. Similar to that, a variable can hold, similar similar type values such as integers, strings, real, can hold similar type of values such as integers, strings, reals, but one value at a time. When you store, you can store one value at a time, similar to the mug. In mug, you can't put fruit juice and tea both. Then it will become like something like kottu, right? Fruit juice, tea, dekama danna bෑනේ mug එකට. Either fruit juice, right? Either fruit juice or coffee or tea, something. Okay, what is constant? Constant is a memory location which is used to store a fixed value. Value is not changing during the program execution. So that is called constant. Value is not changing during the program execution. Example, you can say gravity. It's not going to change during the program execution. Or phi. It's not going to change during the program execution. It remains same. To store that, we use constant. Okay, I got a question from you. Is it correct to write variable is a changing and constant is not changing? It's correct, but incomplete. That's the issue. Correct, but incomplete. So it should explain a variable and constant. Both are memory location. One is changing during the program execution. The second one is not changing during the program execution, and it holds similar type of values. Example is not required. Without example, if you write the same, you will get full marks. Here, 5 marks for this. What are the main features of programming languages? So this is like 10 marks question. So what are the main features of programming language from 1GL to 5GL? Program generation 1 to generation 5. Write only one sentence per each generation. So first generation. Can you explain it using one sentence without using much? What is first generation programming language? Can anyone explain? Yes? Anybody, please? Still writing? Is that? Using transistors? No, I'm asking first generation programming language. First generation programming language. I'm asking about first generation programming language. So first generation programming language, you call it's called machine language and represented by using binary numbers. So that's enough. It's called machine language and represented by using binary number system. It's 1, 0, on and off. How you wrote programs to the computers in first generation using switches. These switches can give 1 and 0, or punch card can give 1 and 0. So that's how you do programming in the first generation. It's one using ones and zeros. No need to convert that because it's originally the machine version of language. So no need of any translators. In second generation onward, only you need translators. Second generation. Binaries are grouped to create assembled textual data. Assembled textual instructions. called assembly language, and it is translated to machine language by using assembler. It is translated to machine language by using assembler. That is the second generation. Right? In second generation, binaries are dropped. So in the first generation, you had only pure binaries. අර switch වලට දෙනවා වගේ තමයි switch එකකට දාන්න පුළුවන් 1 and 0. Right? Switch එකකට දෙන්න පුළුවන් 1s and 0s. So you can see switch when you give 1 or on, switch will turn on. When you give 0 or off, the bulb will turn off. That is machine language. But in the second generation, those are grouped. So these 1s and 0s are grouped to summarize this. Similar to hexadecimals, what you are doing, you take 4 by 4 and write hexadecimal code. Similar to that, these binaries are grouped and represented by using letters, and that language is translated by using a translator called assembler. Please write. Okay. Right, then, so let me show this, right? Let me show this, that if you have doubts about what is binary and what is machine language and what is assembly code, I can show you small thing. Right, okay, just see this. Assembly. And the binary version of this. So it's something like this. So you have, okay. Can you see the screen? If you can see my screen, you can see. So what are the digits in the beginning? So what are these digits? Yes? What are these digits? 4040, 4070, 40404C, 40404E. What are these? Which number system? Which number system? Hello? What is the number system? Yes? You are coming to grade 10 classes. No, is it hexadecimal? Yes. You are coming to grade 10 classes also. Please tell it, because today we discuss about this number system in grade 10 class. So this is hexadecimal. Dase pade. These are called hexadecimal numbers. Right? So, but anyway, what is inside that? So hexadecimals, you know, it can be converted to binary. So instead of these hexadecimals and binaries, so these keywords, these words were used. These words were used instead of hexadecimal and binary. So this is called the assembly language. This version is converted, right? Version that you can see here. This version is converted to this version by using something called assembler. Assembler did the conversion part. So this to this will be converted. This is called assembly language, right? Whatever you can see here, this is called assembly language. Right, that is the second generation. So can you tell about the third generation? Okay, I can include this part also in your note. So for more explanation, let me add that part. So what is third generation? Can anyone tell? What is third generation? Hello guys. Are you sleeping?
So what is the question?
The question is question number 2 in the paper. Question is question number 2 in the paper. I'm asking about programming language generations. Generation number 1 to generation number 5. So now I'm asking about what is third generation. What kind of languages are used in third generation? I'm asking about programming language generations. Yes. Can anyone tell what is third generation language? First generation is machine language. You have to remember these guys. Second generation is assembly language. Okay, the third generation, what is that? Can't remember. Oh my God. So that is called high level languages. High level languages were used, and the translation of these languages to the machine language is done by compiler and interpreters. Compilers and interpreters. That is third generation. The first generation is machine language. Third generation is binary. Sorry, second generation is assembly language. Third generation is high level language. So okay, now what about the fourth generation? And what about the fifth generation? Yes, what about the third generation and what about the fourth generation? So they're asking only write one line, don't write more than one line. So you need only one line explanation. Fourth generation is more human friendly languages. More human friendly languages such as structured query languages were introduced in this generation. So it was more human friendly. It's like English. It looks like English. Okay, fifth generation, actually, you know. If you don't know fifth generation, that is a big problem. So what is fifth generation? Yes. Even after human friendly language, what is in fifth generation? Come on, guys, you're not answering.
Artificial intelligence.
Yes, artificial intelligence. So languages were languages were logic based and independent from human languages. Languages were logic based and independent from human languages. And those were used in artificial intelligence. Those were used in creating artificial intelligence, AI. That is the fifth generation. So if you have written these things, the highlighted areas will get 10 marks. Machine language, assembly language, more human-friendly high-level languages, artificial intelligence and high-level languages, you will get 10 marks. With some minor explanation, it's enough. So kindly write down this. If you missed that, please write down the answer. So if you're coming this, that means if you have not come in previous 2 months, that is also okay. Now you can learn from these questions. කලින් ආවේ නැතත් මේ questions වලින් ඔයාලට ආයි මුලින් ඉඳන් ඉගෙන ගන්න පුළුවන් පුතේ. ඉතින් දැන් පන්තියේ මේ අද හිටියත් සෑහෙන දෙයක් ඉගෙන ගන්න පුළුවන්. That's enough. So those were the five generations. Those are the 5 generations in programming. So you can take a screenshot, right? No need to write down. So later you can write down. Anyway, I'll send this note to you. I'll send this using WhatsApp. You can download and get it printed. Right? But better if you can summarize and write down. But today itself, I'll send this to WhatsApp, right? Don't worry. So take a screenshot for the moment. And so screenshot should be there in your main memory, brain. ඔළුව ඇතුළට ස්ක්‍රීන්ෂොට් එක යන්න ඕනේ හැබැයි ඈ ෆෝන් එකේ ස්ක්‍රීන්ෂොට් එක තිබිලා නම් බෑ. Right, okay. The third question. Draw a flow chart and write pseudocode to print numbers divisible by from. So number should be from within 1 to 100. You are asked to draw a flow chart and pseudocode to print numbers divisible by 5. Okay, so since is there any new student today? Is there any new student, recently joined students? Can you?
Yes.
It's Praveen. Anyone else?
Yes.
Pascal? All right, okay.
Yes, sir.
Right. 2 are there. Anyone else? Others were?
Yes, sir.
Right. 3 are there. Right. Okay. So then okay. Since there are new, I'll explain the symbols from beginning. Right. So let me explain from the beginning. What are the symbols used in flowchart? So can others help? So what is used for starting and stop? Yes. What is used for starting and stop?
Oval shape.
Yes, it can be rounded rectangle or ellipse. Both are okay, right? Rounded rectangle or ellipse. That is for start and stop. So what is used for a process? How to show a process? What kind of symbol you can use to show a process? All students must answer, right? Otherwise, how new students can learn? Right? How a process is shown? Process? Sorry? Arrow? I cannot hear. Yes, square. Square. You can say like a rectangle. Best explanation is rectangle. Rectangle is used for process. Process is rectangle. So what about input and output? Input and output.
Parallelogram.
Parallelogram. Samantarashtra. That is for input and output. Input and output. Both will be represented using parallelogram. What about a decision? What about a decision? What is the decision symbol?
Rhombus.
Yeah, rhombus, you can say diamond, whatever. Okay. That is to show a decision. Okay, so then how to show the connection? So connection is basically shown by using circle. That is to connect. This is called connector. Connector. Right? Connector is shown by using circle. And what about the data flow? Data flow? Data flow is shown by using arrows. Data flow is shown by using arrows. That is to show the data flow. Right now, you know, start, these are the things. Start, stop, process, output, decision, connector, data flow. Now you have to connect these components using this data flow arrows to draw a flow chart. Flow chart is just a plan. That's all. හරි දැන් අදාවත් කමන්නේ කරන්න පුළුවන්. Flow chart is just a plan. This plan shows how to do that using symbols. Okay, let me help. Anything should start. Anything should start. So that is the primary rule in nature. No? Anything should be started. And whatever you start should be stopped. That is again rule of nature. So life begin, and there's an end also. Similar to that, there's a start for anything and there's an end for anything. You started doing O levels, and one day you have to finish doing O levels. You can't do O levels forever. You have to stop that. So how easy the flowchart is, see? කොච්චර ලේසිද කියලා බලන්න පුතේ. Right? So you have to start and stop. Now you get 2 marks, right? So that's why now you get 2 marks because you have started and stopped. That's great. So here, draw a flowchart to write pseudocodes to print numbers from divisible by 5 from 1 to 100. How to start? From which number? Yes. From which number you have to start? And from which number you have to stop? A newcomer can you have to start from 1 and stop from
100.
100. Yes, that's all. So let's start with 1. Okay, I'll tell that. Okay, I'll tell as a process. I'll tell. Okay, let's start with 100. C equal 1. And how to stop? You have to take a decision. When this reach 100, you have to stop. When this reach 100, you have to stop. Right? You have to tell, okay, if this C is greater than 100, okay, then stop. Don't do that. Stop it. Right? You can control that. If this C is 100, stop. Okay, start. Then if it is 100, stop, because no need to do this again. If it is not 100, let's say if it is years greater than 100, then you have to stop. If it is not greater than 100, you can continue. If it is not, you can continue. What to do then? What to do then? You can continue. You can print. Okay, let me suggest easy method. So, right, you can start from 1 and you can go to 100. That is also correct. It's really true. It's correct. But what you can do is you can start from 5 because 5 is the first number divisible by 5. So no need to start with 1 because we have to find the numbers divisible by 5. The first number is 5. 5 is divisible by 5. So let's print that. Let's print that. Let's output that number. Let's print 5. Okay, what is the next number divisible by 5? What is the next number divisible by 5? After 5, what is the next?
10.
Yes, it is 10. Yes.
10.
How to get 10? So you have 5. How to get 10?
C plus C?
Yes, you can make it C plus 5 or C plus C is also okay, but C plus 5. Then it will become 10. Next time that plus 5 will become 15. We'll make it 15. So that plus 5 will make it 20. Likewise, 5 by 5 it will increase. That is easy, right? That is easy go. So you can just connect like this. Using a connector, you can connect like this and see whether this is working program or not. So it start from 5. It will check whether that C is greater than 100. No, 5 is not greater than 100. Therefore, it will go to the no part. And it will print C, that is 5. 5 plus 5 is 10. It will check whether 10 is greater than 100. No, print 10. 10 plus 5 is 15. It will again go and check whether 15 is greater than 100. No. Print 15, 15 plus 5. Likewise, it will go up to 100. 100 is not greater than 100. Print that. C plus 5 is 105. 105 is greater than 100, so stop. So this is the solution. I think it's simple enough. So C plus C, you are asking whether you can use C plus C. You can use and C. C plus C, the first time it is 5 plus 5. The second time it is 10 plus 10. Because C will become 10 then. The next time it is 20 plus 20. Next time it is 20 plus 20. Next time it is 40 plus 40. So it won't give the answer. So you have to apply and see. So you have the freedom. You can use anything and see. Right? Okay, you can draw the flow chart and let me write the pseudocode. Pseudocode means any boruak, onama boruak liyanna puluwan. In pseudocode, you can write any kind of false thing. You can say begin false codes. False code C equal 5. And you can say if or while, or you can say repeat. Print C, and you can say C equals C plus 5 until, repeat until C is greater than 100. When C is greater than 100, yeah, you can just end, stop. Okay, that's all. So that is your simple pseudocode. That's all. Right, okay, so shall we draw this quickly in your book? I need you to draw this, right? So what has happened? It's too much. I just want to remove the line spacing. Oh. Still. Let's use this style. Okay, you can write it. You can draw the flow chart and write the pseudocode. You need to write question also for these things. If you want, you can take a screenshot of this quickly. Take a screenshot of this. Draw a flow chart to write pseudocodes to print numbers divisible by 5. Draw a flow chart and write pseudocodes to print numbers divisible by 5 from 1 to 100. Write the question. Then draw the flow chart. Happen to this. So then draw the flow chart and write the pseudocode quickly. Draw the flow chart and write the pseudocode quickly.